Hi guys, welcome back to the course Network Fundamentals. This is your instructor Manjeet. In this section, we are going to talk about some of the important and key concepts related to networks like DHCP, TCP and UDP protocols, DNS, ARP, network address translation, NAT and VPN technologies. So let's start with the DHCP, that is Dynamic Host Configuration Protocol. DHCP is very commonly and widely used protocol in LAN and wireless networks. So DHCP dynamically assigns the IP address to computer systems, clients, and provide the required details. So have you ever wondered when you go to any cafe, library or lounge where the free Wi-Fi access is there? So you are just provided the SSID details and password if any, and then you just connect to the Wi-Fi SSID and you are online. You don't assign any configuration, you don't assign any IP address, you don't do any configuration on your smartphone or laptop. But if you check your laptop, you will be already having the IP address assigned to you. So DHCP is the protocol behind that. It dynamically assigns IP address to the client or machines and provide the required details to the client to connect to and communicate with the network. So when we say the required details, it is IP address, subnet mask, gateway and DNS server details. How DHCP work? So whenever when any new client or machines come online in DHCP enabled network, it sends a broadcast message to check if there is any DHCP server to assign the IP address. So it's a new system. So new system doesn't know how to connect to the network. So it sends a broadcast that I don't know how would I be able to connect to the network. Anybody there who can help me? And that broadcast message, when received by DHCP, DHCP server respond back that yeah, I'm there and I heard you, I can help you, and that is the job of the DHCP. And then DHCP provides the required details to the client, so like IP address, gateway, DNS, as I already mentioned, so that client can connect to the internet. So that's how the DHCP protocol works. Now let's talk about TCP and UDP. So if you remember the transport layer of OSI model, which is responsible for end-to-end communication between two application or two hosts, TCP and UDP both are transport layer protocols. TCP is transmission control protocol, UDP is user datagram protocol. So purpose of both the protocol is to transmit the data across the network. Both have their own features and their own place depending upon the type of application. TCP or UDP is used for transmission. Now TCP is a connection oriented protocol and it's reliable. The UDP is a connectionless protocol, but it is faster than if we compare with TCP. So TCP is connection oriented. That's the reason it is a bit slower, because it needs to establish the connection with the other end first. So TCP is slower than UDP. TCP has the features of error detection and correction as well. UDP provides the error detection, but it doesn't have the feature of error correction. TCP has the windowing feature to control the flow. UDP doesn't have any flow control feature. So TCP, as I mentioned, is reliable and UDP is fast. So example will be FTP, file transfer protocol. That is one of the example of TCP. And DNS is one of the key server that runs on UDP. So TCP is Mr. Reliable and UDP is Mr. Fast. So that is the key. Now let's talk about domain name system, DNS. So DNS is, in simple term, it translates the domain name google.com or yahoo.com or any website that you browse to its corresponding IP address, because the network understands the language of IP address and MAC address. So whenever you browse any website, DNS is always working and active behind the picture. So imagine a scenario if DNS won't have been there and you need to remember the IP address of each site that you need to access, each site that you need to browse, Microsoft, Yahoo, and it was just impossible to remember the numeric addresses. So it's more like remembering each of your contacts' mobile number or telephone number. So without directory and phone book, it was just not possible. So DNS made the internet usable. So it brought ease of use. So DNS is all about domains. So DNS domains are managed by ICANN, Internet Corporation for Assigned Names and Numbers. If you remember, we discussed this about ICANN and IANA in layer 3 networks section, wherein we discussed that IP addresses, autonomous system numbers, those are managed and allocated by ICANN. And ICANN is the body who is responsible for domains as well. So domains are managed and allocated by the ICANN. So now let's talk about the concepts and terms used in domain name system DNS. So DNS is, first of all, DNS is a hierarchical system. So at the top there is a root DNS server that manages the top level domains like .com, .net, .gov, .org. So the three characters at the end of each website name after dot is the top level domain. So at the top there is a root DNS server that manages the top level domains, or we call TLDs. So TLDs managed by root DNS. Then there is a NS name server that is the designated server to translate the domain names to IP addresses. So the top level is managed by root DNS, and then the domain name itself is managed by the name server. So if we take the example of let's say support.microsoft.com, that is the fully qualified domain name. The top level domain is .com, and then Microsoft is second level domain, and then we have the subdomain that is support. So support is the subdomain, Microsoft is the second level domain, and top level domain is .com. Now let's talk about the various. DNS is a database of the domain names and IP addresses mapping. There are various types of records in DNS. So DNS database. So let's talk about those records. So A records actually maps the domain to the IP address. Then CNAME is canonical name that we can alias for any domain. So it is an alias for any domain. For example, there is any domain abc.com, and then there is another domain owned by the same organization xyz.com. So if they want xyz.com to resolve to the abc.com only, then there will be a CNAME. That CNAME XYZ will point to the abc.com. So whenever any user will open the xyz.com, it will go to the abc.com. That is due to the CNAME that is there in the DNS database. Another example can be like yahoo.com or www.yahoo.com. So when you open yahoo.com, you go to the yahoo.com site, and when you open the www.yahoo.com again, then you go to the yahoo.com. So it's due to the CNAME that is there in the DNS system. And then we have the MX records. MX records are basically those point to the mail exchange servers for that particular domain, which is for delivering and receiving the emails for that domain. And then we have the PTR records. The PTR records are reverse of A records. So A records maps domain to IP address. PTR maps IP to domain. So these are there are other records as well that we are not going to cover in this session. So these are the major ones. Otherwise, there are other records for other TXT records are there. Those are used for various features and security purposes. So there is an exercise for you. Use the NS lookup to check what are you resolving to when you are trying to NS lookup the Microsoft.com or Google.com or Yahoo.com. So in Windows, it's a CLI command. In Windows, you can go to the CLI, and then you can use the NS lookup space the website name, the domain name. You try that. What are you getting when you are trying to resolve any domain that you want? So you should get the IP address that belongs to that domain name. Next, we will talk about the ARP, address resolution protocol. So in network world, whenever any communication between two endpoints happens, it is based on IP addressing, that is layer 3 addressing, and layer 2, that is MAC addressing. So ARP is the protocol that resolves layer 3 IP address to its corresponding MAC address. So network devices maintains a ARP table that has a mapping of IP address to MAC address. So let's take an example. So network device receives a packet, and it has got the IP address, but when looking at the ARP table, ARP database, that device doesn't have the corresponding MAC address. Then it will send a special broadcast request. It will go to all the so all hosts will receive that special broadcast request, including the destination. So destination will see that this is my IP address that is there in that broadcast request, and it will respond back with the MAC address, the physical address. Then host will come to know about the physical address of that destination, and it will update the ARP table and send the traffic to destination. And then we have the reverse of ARP, that is called RARP protocol, that is reverse ARP, that is to resolve the MAC address to its corresponding IP addresses. So we'll stop the session here. So we covered the DHCP, DNS system, and ARP protocols. In the next video, we'll continue the key concepts, and we'll discuss about the netting, network address translation, and VPN. Thanks guys for watching the video. I hope this was informative for you. See you in the next video.